வணக்கம் நண்பர்களே, மீண்டும் ஒரு வீடியோ சந்திப்பதில் மகிழ்ச்சி. ஸோ இன்னைக்கு கிளாஸில் we discuss about most important topic than Biot-Savarts law. Okay, then Biot-Savarts law. Okay, most important. Okay, sometimes direct வரும் இல்லை sometimes a problem கேட்கலாம். Okay, so first how to define statement. So then statement, so then first point, the magnetic field that is dB at a point due to a small current element. Small current element that is IDL. Okay, so then second point, it is directly proportional to current and the length of the element. And sine of the angle between DL and the line joining of the element to the point. And inversely, so உங்களுக்கு ஃபார்முலா எழுதும்போது ஈக்குவேஷன் எழுதும்போது we can understand it statement. Okay, then inversely proportional to the square of distance. Okay, so this is most important, you have to remember those statement. Okay, so first one, the magnetic field that is dB due to a small current element that is IDL is directly proportional to current and the length of the element and the sine of the angle between DL and the line joining of the element and inversely proportional to square of the distance between them. Okay, so next slide la நம்ம formula எழுதும்போது you can easily understand. Okay, so then how to write that mathematical formula. ஸோ நம்ம கொடுத்துருக்க ஸ்டேட்மெண்ட்டுக்கு நம்ம ஃபார்முலா எழுதுனா you can easily understand. Okay, so then dB, so already we have to explain what is meant by a dB. There should be a mu naught by 4 pi then I dl into r cap divided by r square. இதே in magnitude எப்படி எழுதலாம்னா, in magnitude then dB is equal to then mu naught 4i then I dl sin theta by r square. Okay, so the ரெண்டுமே most important. Okay, so you have to remember this formula and also this formula. Okay, so this is the mathematical form for Biot-Savarts law. Okay, so next how to write some of the important point related about the Biot-Savarts law. Okay, important points. So what is the first point? Then Biot-Savarts law is valid only for steady current. Okay, that is magnetostatic. That is first point. Then second point, then direction of dB is given by a right hand thumb rule. most important. Right hand thumb rule and cross product. Then third one, then magnetic field contribution is vectorial, and total field is obtained by integration. So நீங்கள் இந்த மேத்தமெட்டிக்ஸ் ஸ்டெப்ஸ்லாம் போடும்போது இதெல்லாம் கண்டிப்பாக உங்களுக்கு யூஸ் ஆகும். ஓகே, so next it is magnetic analog of Coulomb's law in electrostatic. The next point, this law is universal, applicable, but integration is difficult for complex geometrics. Okay, so those points are most important. Okay, so then Biot-Savarts law only valid for steady current, then it is only for right hand thumb rule and cross product. It is vectorial and obtained by integration, that is Coulomb's law in electrostatics. So it is universal but applicable, but integration is difficult. Okay, so from that Biot-Savarts law, some of the result we have to obtain. So then first one, long straight wire. So இதை நம்ம derive பண்ணி எடுக்கணும், just I have to give the result only. Okay, so the long straight wire ne question இருந்தாலே we have to choose this one. Then magnetic field mu naught by I by 2 pi r. Okay, this is the most important. Okay, sometimes problem கேட்பாங்க. Okay, so then second result, then circular loop, most important, circular loop center. அப்போ B is equal to then mu naught I by 2 r. So this is the two important result obtained from Biot-Savarts law. Okay, so ரெண்டுமே வந்து most important. Okay, one is long straight wire, then another one is a circular loop. Okay, so next Ampere's law. So then how to define, then statement, sometimes statement ஆவே கேட்பாங்க. ஓகேவா, so the line integral of magnetic field B around any closed loop is equal to mu naught times of total current enclosed by the loop. So mathematically எழுதும்போது you can easily understand the statement. Okay, but then how to write mathematically? So B is equal to the magnetic field into dl, then mu naught I enclosed. So this is the most important formula you have to remember it. Okay, so this is the statement for Ampere's law. So that is the line integral. This is the line integral of magnetic field B around closed loop DL is equal to mu naught times of the total current enclosed by the loop. Okay. So some of the important point. So then first point, then it is applicable. It is applicable only for highly symmetric current. Symmetric current distribution. The most important. Then second one, it is useful for infinite state wire, then solenoidal and toroid. So then third point, then magnetic field is constant along Ampere loop because symmetric, due to symmetric. So then fourth point, it is fail for non-steady current. Non-steady current, that is its need for Maxwell correction. Okay. So then it is a global law, then unlike Biot-Savarts law, which is a local law. Okay, these are all the important points. You have to remember that. Okay. So then based upon the slides, we have to make some of the MCQ. So then which one is correct? Then question, a long straight wire which carries current I at a distance R, then magnetic field B is proportional to. Then solution, then current I, then R is the distance, then magnetic field is proportional to என்னன்னு கேட்டிருக்காங்க. So we know the formula for Biot-Savarts law. Here முன்னாடியே சொன்ன நம்ம நடத்தும் போதே சொன்ன there should be a two result. Long straight wire வந்தாலே என்ன formula கொடுத்தா from the final result. Then B is equal to mu naught I by then 2 pi R. This is for long straight wire. Okay, then most important result. Then another one is circular loop கொடுத்தோம். அப்போ here B is proportional to which one is? B is proportional to, that is I by R. So this is the given in question. Appo what is the correct answer? Option B is correct. Okay. So then what is the second question? Then Ampere's law is preferred over Biot-Savarts law when? So இதுமே நம்ம முன்னாடி பாயிண்ட்ல நம்ம கொடுத்துருந்தோம். Okay. So then what is the solution? So then Ampere's law simplifies only when magnetic field B is constant. எப்போ along the loop. இந்த பாயிண்ட் எல்லாமே நம்ம சொல்லியிருக்கோம் முன்னாடி. ஓகேவா, along loop. இது எப்போ ஹேப்பன் ஆகும்னா only asymmetric. ஸோ இதெல்லாம் இந்த இம்பார்ட்டன்ட் பாயிண்டில் நம்ம கொடுத்துருக்கோம். ஓகே, ஸோ மோஸ்ட் இம்பார்ட்டன்ட். அப்போ ஆப்ஷன் சி இஸ் கரெக்ட். ஓகே, so then question third, then in Biot-Savarts law the magnetic field is 0, then when angle theta between DL and R is So how to write? We know the formula. That should be a Biot-Savarts formula. Number 2 கொடுத்துருந்தோம். is equal to then dB is equal to mu naught by 4 pi then I into dl vector into r cap into r square கொடுத்தோம். இன்னொன்று in magnitude and dB is equal to mu naught 4 pi then I, another one is said dl into sin theta or r into sin theta. Okay, அப்போ here what is the question here? Then dB நம்மளுக்கு இதுதான் வேணும். ஓகேவா, sin angle தான் கேட்டிருக்காங்க. அப்போ then dB is proportional to sin theta. அப்போ இங்கே என்ன கொடுத்துருக்காங்க? So here magnetic field is 0 when angle theta. அப்போ for theta is equal to 0 degree na, அப்போ sin 0 which is equal to 0. Option A is correct. Okay, so next assertion and reason. ஸோ எல்லாமே நம்ம இந்த பாயிண்ட் எல்லாமே நம்ம முன்னாடி கொடுத்துருக்கோம். ஓகேவா, தென் இம்பார்ட்டன்ட் பாயிண்டில் கொடுத்துருப்போம். ஸோ ஃபர்ஸ்ட் ஒன், தென் Ampere's law cannot be used for arbitrary shaped current loop. Then reason, then magnetic field is not constant along Amperean path for such geometric. ஸோ இது ரெண்டு பாயிண்ட்டுமே நம்ம அந்த இம்பார்ட்டன்ட் பாயிண்டில் நம்ம கொடுத்துருப்போம். ஸோ among those cases which one is correct? Then both A and R right and R is the correct explanation for A. So option A is correct. ஸோ இது ரெண்டுத்துக்குமே நம்ம எக்ஸ்பிளனேஷன் வந்து இம்பார்ட்டன்ட் பாயிண்டில் கொடுத்துருக்கோம். ஓகே, யூ கேன் கோ த்ரூ இட். Okay, so from the match the following, which one is correct for infinite state wire? So already நம்ம கொடுத்துருக்கோம். Okay, what is the infinite state wire? Is correct answer for C, which is 1. So then circular loop ku correct answer B. Okay, so then similar for long solenoidal, the correct option is A. Then toroid ke D. Okay, so this is the correct option from this match the following. Okay, so நன்றி நண்பர்களே, மீண்டும் ஒரு வீடியோவில் சந்திப்போம். நன்றி, வணக்கம்.